Hey everyone. It's really good to see all of you in person here in San Francisco, and the online viewers as well. It's also good to see you. So, this is a Data and AI Summit, and I wanted to speak with you today about data-centric AI development and the shift from big data to good data. Over the last 10, 15, 20 years, I've been excited about the work that all of us collectively have been working on to democratize access to AI. And I think AI machine learning can't reach its full potential until it's accessible to everyone. And for the next step of that journey that I think all of us are on together, data-centric AI will be key to unlocking that next era. But what does that mean? Over the last many decades, the conventional approach to machine learning and AI development has been the model-centric approach, in which you know that AI systems require writing code to implement your algorithm or your model, and then training that on data. And the conventional paradigm for a lot of machine learning development was to download the data, hold it as fixed, and then iterate on the code or the algorithm or the model. Thanks to this paradigm of development, we've collectively made a lot of progress in developing modern neural network and decision tree and other architectures. Because of that, I find that for a lot of practical applications, I know many practitioners here, I hope this will resonate with you. For a lot of practical applications, it's become more efficient to even hold the code fix, take a good modern implementation of a neural network, do a robust hyperparameter search, but beyond that, to then focus more of your attention on entering the data. So data-centric AI is the discipline of systematically entering the data used to build an AI system. And my experience has been, for many applications, I've gone to a team and said, hey everyone, that cutting-edge neural network thing you have, it works just fine. Let's stop messing with the code. The only thing we'll do is engineer the data, and giving that direction to the team resulted in faster progress. But the shift to systematically entering the data is, I think, where all of us, I hope, can get better at. You may have seen studies like this, widely cited McKinsey one, estimating that AI will change all industries, from retail, travel, transport, logistics, and many others. But candidly, when I look across many different companies, I see AI having transformed consumer software internet companies, tech companies, but its impact on all of these other industries feels much more nascent. And why is that? Let me share with you what I think are the two biggest barriers to AI adoption in the rest of the economy and the rest of the industry. First is small data sets. I've been doing a lot of work in computer vision, learning AI, been writing software to make computer vision super easy. And so been talking to manufacturing customers, for example, about their computer vision applications. And it turns out that I asked the manufacturing audience, how many images do you typically have of defects you want to detect? Manufacturing something, take a picture, you want to detect defects. And this was the answer given by the manufacturing audience, where the most common answer was 50 or fewer images. I once built a face recognition system using, I think, 350 million images. But in tech that we built for hundreds of millions of images, it just doesn't work when the data set sizes are much smaller. And there are a lot of applications outside consumer software internet where you do not have a billion users or hundreds of millions of users, and the data sets are just much smaller, and you either have to get it to work on a small data set or else it's just not going to work. The second barrier to widespread adoption is, I think, the customization or the long tail problem. Here's what I mean. If you were to take all current and potential AI projects and sort them in decreasing order of value, you might get a curve that looks like this, where maybe the single most valuable AI model in the world, maybe some online ad system for some large website. Maybe the second most valuable is some web search thing. Maybe the third most valuable is some product recommendations thing for online e-commerce. And so our community, we figured out for these hundreds of millions of dollars or billion-dollar applications, how to get a large team of dozens or even hundreds of AI engineers to build it, deploy it, maintain it. We know how to do that. But once you go to other industries, take manufacturing, where I've been doing a lot of work. There could be a company making pharmaceutical pills that needs to inspect them, or a separate company making sheets of steel that needs that inspected, or another company making semiconductor wafers that needs to inspect that. And what I'm seeing is that there are a lot of $1 to $5 million projects that are individually valuable, but that we don't yet have the right recipe or the right way to execute. And there are, I think, tens of thousands of these projects, and the collective value of all of these projects in the long tail, I think, could be even greater than the value of the projects in the head. But once you go outside consumer software internet, you no longer have these giant databases of homogeneous users. And so the challenge is, how do we help various industries get these tens of thousands of projects executed without any one company having to hire tens of thousands of machine learning engineers to go in to do all the customization? This is an AI industry-wide problem. And I think the only way out of this dilemma is to build vertical platforms that lets the end customer do the customization, to let the IT personnel in the manufacturing plant build and train their own custom AI model. And so I think to democratize access to AI, to make it accessible to more people, we need vertical platforms that enable the end customer to build the custom AI system that they need. And they do need a custom AI system because pictures of pills look nothing like pictures of sheets of steel, look nothing like semiconductor wafers. And so each of them, they just need a custom AI system for whatever they need to inspect. Now, if you were to go to the IT personnel of a manufacturing plant and say, hey, I need you to invent the next generation of transformer neural network architecture or something, that's actually pretty challenging. But I think that a more accessible path to empowering a lot of people to build AI systems is provide tools to engineer the data, because it's by empowering people to engineer the data that they can then express their domain knowledge about what is the defect in a pill, what is the defect in a sheet of steel, and so on, so that they can express the domain knowledge to build the AI system that they need for their application. Hence, data-centric AI. Excuse me. My son started daycare a few weeks ago. I keep catching these bugs from him, but I tested negative for COVID today and yesterday, so I should be okay. Yeah, those of you with kids very empathize. Thank you. First time someone clapped for me coughing, but thank you. So when we start to engineer the data, especially on problems where we have smaller data sets, I've been surprised over and over at how effective you can build a machine learning system with just 50 images, so long as the data is well chosen and accurately labeled. So if you don't have big data, I try to strive for good data, but what does that mean? If you're building a supervised learning system to learn an input X to output Y mapping, say computer vision, input an image, output a label, what does a good data set mean? I think a good data set should have consistent and accurate labels, Y. The inputs X should be representative of the data distribution and be high quality. And the data should also reflect post-deployment changes, reflect concept of data drift, if any. Let me dive a little bit more into detail in some of these concepts with some illustrations. So consistent and accurate labels, why? If you're inspecting a pharmaceutical pill, this is like a small, 1 centimeter wide pharmaceutical pill, it turns out that labelers will often, well-meaning, hardworking, very smart labelers will often label images inconsistently. For example, labeler 1 may label that a chip, labeler 2 calls it a scratch. Who's right? I don't know. Either of them could be right. Or inconsistency in bounding box sizes. One labeler will say, oh, looks like the discoloration is here. Second labeler will say, looks like that's a discoloration. Neither of them is wrong. I find that when labelers are inconsistent, it usually means I didn't write clear enough labeling instructions. Or labeler 1 may say, let me draw a bounding box to show you the chips. Labeler 2 might say, oh, let me draw the bounding box there. So well-meaning, hardworking, very smart, very experienced labelers will label images inconsistently. And what I've seen is many data sets where these inconsistencies just sit there for months or years or even longer. And this makes the thing you're trying to learn very confusing for the learning algorithm. So let me go to my laptop. Well, all right, a lot of laptops here, and show you a quick demo. So my team's been executing a certain recipe in computer vision, but I'm going to share this recipe with you because I think others hopefully can execute this recipe in other domains as well. So we found that one of the almost basic features that turns out to be very helpful is a team editable, we call it a defect book or label book, to let the team collaborate to clearly define what exactly you want to label images as. So for example, and surprisingly, we found that having teams spend a lot of time discussing and debating these label definitions. What is a discoloration? How do you want to draw the bounding box? What is a scratch versus what is a chip? and then to give very clear labeling instructions where to draw the bounding box. This is kind of stuff that found that teams spend editing these labeling instructions has some of the highest ROI of the various things that a machine learning team might do. Could we go back to the slides, please? Cool, thank you. Oh, excuse me. It turns out that even the most revered data sets in machine learning, the classic data sets you read about on the news, have errors in them. For example, ImageNet. This image was labeled tub. This image was labeled a passenger car. This image in MNIST was labeled 8. And that was labeled a 1-star review. So actually, there's a really nice paper by Northcutt that pointed out some of these errors and even some of the most revered data sets in machine learning. And so I think for a lot of our data sets, especially if you want to work on small data sets, you want something to work on 50 images or 100 images or just hundreds of images rather than millions of images, the ability to have tools to align on what is the right label and clean up labels will make a huge difference to your algorithm's performance. I find that thinking of data engineering as part of the ML workflow has also been a shift in my thinking, a lot of teams thinking as we shift from model-centric to data-centric AI development. So many of you will have seen something like this workflow where you train a model and then carry out error analysis to see where the algorithm isn't working well enough yet. And then we would go back to tune the model, tune hyperparameters, learning rate, neural network architecture, whatever. Shift is instead of tuning the model, we instead think about how to tune the data. Where if something isn't working well enough yet, let's go back and see how you can improve the data. And I think data cleaning, I no longer think of it as a, quote, pre-processing step that you do once before, like the real work of machine learning happens. I don't think that's the right way to think about it. I think data cleaning or improvements to the data is a core part of the iterative process of machine learning development. We used to tell these jokes like, hey, did you know 80% of machine learning is data cleaning, like it's a joke. But to me, if 80% of our work is improving the data, then that is the core part of a machine learning engineer or data scientist. And where we should work toward is better tools to make that data improvement process much more systematic. Now, one key idea is we always want better data, but when we have a data set, even dozens or hundreds of images, how do you make the data better, right? You can always kind of look at everything. There's just too much to do. When you have so much data, where do you focus your attention? So I want to show you another quick demo of agreement-based labeling, which is a tool. Could you go back to the laptop, please? To help show where one might want to improve the data. So let's see. In this example, we had 3 labelers, Michael, me, Andrew, and Nicole label the data. And we're not having 3 people to label the data to just vote, right? A lot of crowdsourcing, let's have a whole bunch of people label it and then take the average. You could do that when you have massive data sets and massive labeling teams. But I think it's even more interesting when we build tools to identify where labelers disagree. So we have 3 people label this small data set and have computed an agreement score. So this image has a high agreement score. Michael thinks that's the defect. I think that's the defect. Nicole, me, Michael. Very similar. Let me sort it in. Look at the images of the lowest agreement score. For this image, Michael drew a bounding box like that. I drew bounding boxes like that. And Nicole drew a bounding box like that. And the purpose of a tool like this is it allows you to ask a few labelers to label similar images, not for the purpose of just taking a vote, but for the purpose of surfacing where exactly are the disagreements, so you can get the team together, revise the labeling instructions, and then drive the labeling team toward a higher level of consistency. So this level of automation to enable collaborative workflows has turned out to be an efficient way in the projects I've been working on at Landing AI to help many teams quickly improve the quality of the data and get good results, even if you have only dozens or hundreds of images or relatively modest data set sizes relative to the stuff you tend to read in the news. Can we go back to the slides, please? Thank you. So, when you have a large data set like this, how do you know what's wrong with the data, right? You kind of want to look at every image, check the labels, it's just too much. But tools like agreement-based labeling lets you have a systematic way to focus on the slice or the subset of the data. We say of all of these images, it looks like that subset. Maybe the chip defect is a problematic one. It lets you focus your attention to have the labelers figure out, oh, you agree just fine on scratch and discoloration, but the chip defect, that's where the problem is. So you focus attention and improve just a slice of the data where it's problematic, and that causes teams to be much more efficient with these collaborative tools. And in terms of improving talk about quality of Y, also quality of X, I think that tools that help you surface problems in the data also help you figure out where your inputs X have a problem. So for example, if I give you these 6 images and ask you to detect pills in pharmaceutical pills, I don't know, can't really tell what's going on. But if I take out those 3 images, which were poorly imaged, poor focus, poor contrast, and leave just those remaining 3, your data set, even though it's half the size, is actually much clearer. So I find that one of the things we sometimes don't do enough of is take images like that on the left and work on, that's really blurry, right? But work on the imaging design and work on the sensor modalities in order to, so we just adjust the contrast and focus and create a much higher quality image. But again, data has so many problems that tools to help focus your attention on the subset to work on is really important for driving the team's performance. And in fact, on the same theme, we always want more data, right? Machine learning, hey, I'd love to have more data. But again, if you ask the team to go out, please collect more data, that's very difficult because there's so much data to collect of everything. But when you have tools, error analysis tools to tell you, of all of this data, maybe the subset that you have the hardest problem, the biggest problem with is a scratch defect. So instead of collecting more data of everything, I would like the labeler team or the image acquisition team to just collect a lot more pictures of scratches. Don't worry about discoloration, don't worry about chips, just collect more data of scratches. Then again, the data acquisition team can be much more targeted, much more efficient in terms of where to focus attention to collect more data. I think for the last few decades, experienced machine learning engineers have been doing this intuitively. Some experienced person will walk in and say, hey, look at this, let's get more pictures of scratches. But the tooling to make this more systematic will help democratize access and set up a lot more teams for success. Now, before I break, there's one more core idea I hope to share with you, which is that machine learning has always been a very iterative process. And I find that as we shift toward data-centric AI, the ability to iterate quickly has become even more important. When I was in an early stage of machine learning, when I spent most of my time tuning neural network architectures or hyperparameters, I train a model, do error analysis, and then you say, all right, I want a bigger neural network. Or maybe swap out YOLO for ResNet, or change the neural network architecture or something. But those moves, they weren't always that intuitive. But when you're entering the data, it actually feels very organic. I train a model, I say, oh, made a mistake there? Well, let me label more images like that. Or, oh, made a mistake there? Looks like I messed up my labeling. Let me fix my labeling errors. And so examining data for subject matter experts or for machine engineers or for data scientists is actually very intuitive because look at the picture, see what's wrong, fix it, and move on. And the ability to iterate quickly through this loop has a huge impact on driving developer productivity. And this is true. Can you go back to the laptop, please? This is true both for pre-deployment development as well as for post-deployment monitoring and adapting of the model to get data drift and concept drift. So let me show you a quick demo. By the way, actually, do you all, I've been Landing Lens, we work on everything from, I don't know, aerial imagery to pharmaceutical inspections to look at cells under microscope slides to a lot of medical imaging applications, agriculture applications. But actually, do you guys have a preference? Would you rather see a segmentation demo or a object detection demo? You guys? Both? Boy. Wait, all right. I'm hearing very mixed shouts. You know what? Let me do the segmentation one. All right, just to show something different. So spend a lot of time thinking about how to make computer vision super easy. So this is a data set where cereal, and you want to detect foreign objects, like screws that may be in the food supply. And so common, labeling interface, quite standard, right? Upload images, label it, and so on. I label all but one image. There, just label that image. And then um, put a lot of time into developing a UI so that you can um, upload. I guess we have 27 images. You saw me label one image in like, I don't know, 4 or 5 seconds, and then with auto ML-like features, upload the data set, label the data set, and then click a single button and have a learning algorithm train a model for you. And because data-centric AI feels so organic, it's human in the loop to fix the data, empower subject matter experts to look at what's wrong and fix the data, and fix a few labels, retrain, fix a few labels, retrain. You can iterate very quickly. And so to make computer vision super easy, which is what I've been focused on, but I hope you take this type of recipe and apply it to other applications as well, I find that having a workflow that lets you have an intuitive UI like this, upload images, drag and drop, draw a bounding box like I just did, upload a defect book if you wish, and then click a button and have a lot of the hyperparameter tuning or choices of the hyperparameter automatically chosen. That makes the developer, much more efficient, right? Maybe while this is running, should finish in just a minute, right? For image segmentation, kind of very similar workflow, right? Sorry, all right. Well, a variety of labeling tools, some with more intelligence than others. And again, whether it's image classification or there, just label that, not a great label, and click change. Oh, all right, good. And so the model's finished training. And so this is the entire data set, right? And you never know what's going to happen with these live demos. This is actually a live demo, just trained in the cloud. So look at the depth set images. So the algorithm did not train on these images. It actually looks pretty good, right? It's finding, hopefully it's like this is an honest real training. I labeled one image as trained. I actually honestly didn't know what was going to happen. Looks like it actually did a pretty good job finding the screws in the development set, right? And so can we go back to the slides, please? So what you saw me just do was in 3 minutes label one image. I technically need to label dozens of images and train a model. And so sometimes in just minutes, you can go through this development loop and drive very rapid progress of your learning algorithm. Right? All right, let me just wrap up. Even though I've talked about computer vision, because that's what I've been working on, at Land AI, a lot of the ideas I talked about are a recipe that I hope many others as well can execute in other domains in computer vision to take these ideas and empower a lot more people to use cutting-edge machine learning. Over the last 10, 15 years, scaling up data sets and models has driven a lot of progress. In fact, 10, 15 years ago, I was shouting loudly, let's start using GPUs, let's use big data, right? But collectively, the community's made a lot of progress scaling up models and data. But with the maturity of today's models, I think many, not all, many applications will make faster progress if we instead shift to entering the data. With technology development, you often see this pattern. Initially, a handful of experts will do something intuitively. So maybe 15 years ago, there was a handful of experts coding up neural networks in C++, right? Error-prone, but a few people get it to work. And then with publications, the ideas become more widespread, and then a lot of people could code up neural networks in C++, so still kind of error-prone. And then eventually, there were tools like TensorFlow and PyTorch that made the application of deep learning more systematic, and that empowered a lot more people to successfully build deep learning models. In the case of data-centric AI, I think we have been here for a long time. We've had experts intuitively make data decisions. I think we are now firmly, many teams publishing papers, letting the principles become more widespread. And I feel like where we need to go as a community still is to build more tools to make the application of these ideas more systematic. Because also then, it would be great if we can empower the subject matter experts in the factories, in the hospitals, the logistic networks, and the aero imagery companies, all of those companies to build their own AI systems. What I did not talk about in this talk are structured data. Data-centric AI absolutely applies, but the principle is a little bit different, and data pipelines and data cascades, which tends to add a lot of complexity to data-centric AI, but many of these ideas are still very important for entering the data. And I just want to share additional resources. My team at DeepLearn.ai publishes a weekly newsletter called The Batch. Actually, I think we have an issue going out today to talk about career advice for AI developers, machine learning engineers. But I often share cutting-edge observations about data-centric AI in the batch. So go to thebatch.ai on your cell phone and subscribe to that if you want to get updates. And with collaborators been building up data-centric AI resource hub to try to get the community to build and share these ideas more broadly. So with that, let me wrap up and say, democratizing access to AI will benefit everyone, and I do think that is this community, the data and AI community, that holds the key to fleshing out the ideas and tools for data-centric AI to unlock this next era. Thank you very much.